Hello everyone, myself Sweta. Today I am going to discuss a most important topic which is asked in the organic chemistry, which is mainly asked in the very competitive exam, that is from the organic chemistry, that is the aldol condensation reaction. So aldol condensation reaction mainly consists of comes under the reactions under the alpha reaction which consists of alpha hydrogen. So what is aldol condensation reaction? A compound which consists of alpha hydrogen atom, when it reacts with the dilute base, and base we can take any base also, in the presence of heat it gives an alkene. So let's see what's happened in the aldol condensation reaction. First of all, we will take an aldehyde group. Here is the functional group which is known as the carboxylic group. Its neighboring carbon, which we can call as the alpha carbon, which consists of 3 hydrogen. This hydrogen are called as the alpha hydrogen. We can also call it as an acidic proton. This hydrogen as an acidic proton. Why we are calling it as an acidic proton? As the carbon is more capable of donating this H plus ion, so we are calling it as an acidic proton. We will take a base. Base we are taking as dilute NaOH, that is sodium hydroxide. Sodium hydroxide will break to form Na plus and OH minus. This one is the OH minus, act as a base. It will take H plus ion, abstracted proton from the carbon group, this is carboxylic group, and form it as a C double bond O H, C negative, hydrogen. Now this complex or compound we can take it as a nucleophile, which we will see further. This complex, in order to become stable, in order to attain the stability, it undergoes the resonance. How it is going under resonance? See, this negative ion goes here, and this carbon oxygen bond, pi bond break to form H, C, O negative, C double bond C, H and H. Like this resonance happens here. One question will arise in your mind, that why it is showing resonance. So the answer will be, why it is showing resonance, as the oxygen is more electronegative group, it tries to extract the electron from the carbon and form it as a negative charge. So it is showing the resonance effect, and it attains the stability. Now we will move into that how this complex, how did all the one question will arise in your mind, that did all the acetaldehyde and ketones shows the aldol reaction? We will see. First we will take the example of formaldehyde. And we know that in aldol condensation, what happened when an acetaldehyde or acetone or ketone, when react in the presence of dilute NaOH in the presence of base, it will give an alkene. So we are taking the formaldehyde in the presence of dilute NaOH. Does it shows the aldol reaction? Does it contains the alpha hydrogen? No, it does not contain. It doesn't contain the alpha carbon. It doesn't contain the alpha hydrogen. So it will not show any reaction. Second example we will take of benzaldehyde. Here, when benzaldehyde treated with dilute sodium hydroxide as a base, then Does it form any reaction? The answer will be no. Why no? It also, one question will arise that it contains the alpha carbon. Then why it is not showing the aldol reaction? As because it does not contain the alpha hydrogen. Here we can see the benzene group. Here the carbon shows the tetravalency which is stable, but it does not contain any hydrogen. So this benzaldehyde doesn't show any reaction. After that, we will take another example of acetaldehyde. When an acetaldehyde treated in the presence of dilute sodium hydroxide, that is the base, then this reactions happens, and we will get, it will abstract in one proton from the hydrogen, and aldol reaction will form. Now we will see this reaction in the form of mechanism. So here is the mechanism of acetaldehyde. What happened here? When an acetaldehyde in the presence of dilute NaOH as a base is treated, here the OH, which is act as a base, it abstracts the proton from the acidic, it takes the acidic hydrogen and forms the water, and this forms CH2 negative CH2. Okay, this part work as a nucleophile, and again it react with the 1 unit of acetaldehyde to form this complex. So this complex, what happened? As we know that C double bond O, oxygen is more electronegative, so it will abstract and carbon is positive. It acts as a carbon cation, and this carbocation, and this one work as a carbon anion. So nucleophile act towards this in order to attain the stability. Pi bond breaks, oxygen becomes negative, and this happens. This CHO comes here, then CH2, this negative part attack with this carbon, carbocation, and this C double bond O, CH3 form. Again, we will treat with the water, then H plus and OH breaks. OH again, H plus proton goes towards the oxygen, forms this CH3, CHO. Here, this is CHO is the main functional group. We will take after that carbon, functional group CHO group, the next carbon consists of alpha. After that, we will name it as a beta. So, how we are telling it as a complex? We are calling it as an alpha beta hydroxy compound. Here, the carbon consists of hydrogen, and the beta carbon consists of OH group. How we will name it as an aldol reaction? How? See, this functional group consists of aldol, and this OH group consists of OL. So together we can make it as an aldol reaction and name it as an alpha beta hydroxy compound. After that, what we will do? We will do the next step, that is the condensation step. We will heat it to form it as an enol or ketone form. Now we will take some examples, or we will take or we will do a short trick in order to do it in a fast manner. We will not go through the whole mechanism, and it will become a lengthy process. So we will take a shortcut to understand this. So first of all, we will take this one CH3 acetaldehyde, 1 unit, and it is treated with the dilute NaOH. Is the first step, and the second step is the condensation part, that is heat. So we will hang these two hydrogen like this and this. After one more unit we will take. This only is coming here. Short trick. What we will take? We will remove this water and will form, and the complex is formed. This CHOH CH. This part again we will take the double bond, C double bond H, then CH. Like this we can form it as an Aldol reaction. Next example we will see. Another different example we will take, like when we will treat it, this is acetaldehyde group is there, treating with the dilute base, so sulfuric this water will be removed and we will get this C double bond OH, CH double bond CH, then C2H5. So the answer will be like this. Like this we will form an aldol condensation reaction. I hope you can understand this. Thank you.